We're going to do another method of multiplying polynomials today. If you remember last class, we learned the Punnett square method, where we multiplied the different parts of the binomials or trinomials together to create 6x squared, 10x, 9x, and 15. We added on the diagonal and then had our trinomial 6x squared plus 19x plus 15. Okay, that's what we did last class. We're going to be doing a similar method, but this is called double distribution. You might hear some math teachers and mathematicians call this the FOIL method, because the FOIL method, F-O-I-L, gives us a hint of what we're multiplying together. But this is double distribution. In my opinion, it is a more efficient and faster way to multiply. So when we will be quickly checking our work later on in this unit, you're going to need to be able to double distribute along with me, or else use the Punnett square method that I probably won't show anymore. So the double distribution method is basically saying I'm going to take this first term in the first parentheses and I'm going to distribute it like normal. Okay? Little arrows. So we're taking the first numbers in each of the parentheses and multiplying them together. That's this. So that's 3x times 2x, that's 6x squared. Then we're going to take that same first piece and continue to distribute it, because it needs to be distributed to both pieces. 3x times 3, that's 9x. Then we're going to switch. We're going to take the second piece, the second part of that first parentheses, and distribute it like normal. 5 times 2x is 10x, and 5 times 3 is 15. Now, hopefully, you might recognize that, hey, these are all the same numbers that I got in the Punnett square method, because you're right. Additionally, you're going to notice that there are like terms instead of on the diagonal here in the center of this polynomial. Now, if they're not in the center, if you have a weird shaped polynomial and they're not actually there, you do just look for the like terms. And we finish adding everything up, and again, we end up with a bigger or trinomial product between these two binomials. This is exactly what we got when we did the Punnett square method and we combined our like terms on the diagonal. But you don't have to draw a box, circle it, add everything up. You just multiply as if there were two distribution problems, the 3x getting distributed and the 5 getting distributed. Now again, we call it the FOIL method because when we're multiplying this, we're multiplying the first terms in each parentheses. Okay, these are the first terms in the parentheses. Then we multiply the outer, F-O, then we multiply the inner, I, and then we multiply the last. So it is just a fun way, an acronym for double distribution, but you're just distributing the first thing in the parentheses, then the second thing in the parentheses. Double distribution. Now we will practice essentially the same problems today, and instead of using the Punnett square method, we're going to use this double distribution or FOIL method. But we're also going to finally tap into dividing polynomials. Now we're going to do a very specific type of dividing today. It's going to be called dividing the GCF. Now you've heard of a GCF before, but it's probably been a minute. So if you think back, you'll remember that the GCF is the biggest number or variable. I'm going to shorten that to vars. So biggest number or variable that all terms share or have in common. I mean, it's right there in the name. You're looking for the biggest, aka greatest. You're looking for the thing that they share, aka common. And you're looking for the things that multiply together to create the term, aka factor. Greatest common factor. Now this very first time we do this, I'm going to do a lot of extra work that you won't need to do if you can just look at this trinomial and tell me what the greatest common factor is. But if we break apart each part of this, each term from this trinomial, you'll have 3 and x times x. That's what I'm multiplying together. Those are the factors. And then if I look at the factors of 6x, you've got 2 times 3 times x. And if I look at the factors of -9, this is going to be -3 times 3. Now, if we look at this and we're looking for the greatest common factor, you can see that they share a 3. They don't all share x's, so we would say that when we're identifying the GCF is 3. But now not only are we going to be done if we can just say what the GCF is, we actually are going to need to divide or factor out the GCF. You're going to hear me start to use that phrase, factor out. That is how we call dividing in most cases for polynomials. So divide or factor out, factor the GCF. Now what that means is simply that I'm going to take this polynomial and I'm going to divide away that GCF that they have in common, which means each and every piece of this gets divided by 3. Now that 3 goes in the very front of parentheses, okay? See, this is my GCF. And then I'm going to open a set of parentheses and I'm going to put what's called the leftovers in there. Now that is not official math terminology, but we're going to call them the leftovers. Okay, when I actually do this division problem, 3x squared divided by 3, that's x squared. 6x squared divided by 3, that's 2x. And negative 9 divided by 3, that's negative 3. So I have divided out or factored out my GCF when I take the GCF out of each and every term and leave the leftovers in parentheses. That is dividing out or factoring out the GCF. Now, that is what we're going to practice today and in class. So let's go ahead and switch to the inside of these little notes. And let's do 4 problems of multiplication and 4 problems of division. Remember, dividing out just the GCF today. Instead of drawing my Punnett square box, we are going to use double distribution or the FOIL method. That tells me that I'm going to multiply the first things in a parentheses. This is the first distribution. X times x is x squared. Then I'm going to go to the outside, again, still just distributing that x. This is going to be 1 times x, or 1x. Then I'm going to multiply what's inside, or just start that second distribution. 9 times x is 9x. And last but not least, finish up with what are last in the parentheses, or, finishing that distribution. We have double distributed. Both pieces here have been distributed to the second parentheses. I've multiplied everything. Hopefully, again, you notice that my like terms here are in the center, so I can add those two things together. That's going to be 10x. And then just float down my constant and my x squared term, and know that that is the equivalent product for those two binomials that are being multiplied together. For those of you who feel like we're doing something completely different, I just put the Punnett square method version of this problem on your screen so you could see that we're still essentially doing the Punnett square method. We're just going to be doing it without the help of the box because we're still getting 4 different multiplication problems when we do double distribution. Again, I recommend getting good at double distribution as opposed to the Punnett square method because this method is a little bit faster, takes up less paper, and everybody's happy. Let's do this second one together before we get to some crazy problems. Remember, we're going to be double distributing. So what I'm going to do right now, just to help you get the idea of double distributing, is I'm going to cover up that second part of the first parentheses. You don't do that because we're going to need it in a second, but I can erase and still see it. This means that we're going to double distribute x times 3x. That's 3x squared, as if I was just distributing the x. X times 2, that's 2x. Great. Now I'm going to uncover that second part of this parentheses and cover up the first part of this parentheses. Now I am distributing the negative 4. Negative 4 times 3x, that's negative 12x. If you don't believe me, consult a calculator. And negative 4 times 2, that's negative 8. So it really is just distributing twice. Again, you notice that the like terms are in the center. 2x plus negative 12x is going to be 10x. And I can float down my constant and my x squared term. And I have my trinomial product for these two binomials. I want you guys to pause the video on number 3 and try it yourself. Okay, the question's going to ask you what the answer is, or the product is, so make sure you do this problem on your own. Hopefully this is what you got as your trinomial product for these two binomials. Okay, again, we are just multiplying as if this was a Punnett square, or as if this was distribution by first distributing the 2x to both pieces of that binomial. 2x times 6x is 12x squared. 2x times negative 5 is negative 10x. And then we uncover that second part and essentially cover up the first part so that we distribute for a second time, hence double distribution. Negative 3 times 6x is negative 18x, and negative 3 times negative 5 is positive 15. Then simply all we have to do is add the like terms here in the center. Negative 10x plus negative 18x is negative 28x. Now this next problem isn't going to work if you've used the FOIL phrase because it's bigger than a 2 by 2. If we were doing this with a Punnett square, this would have been a 2 by 3 rectangle instead of a Punnett square. It would have been my Punnett rectangle. Remember that joke? So for this one, we're going to need to do more than just firsts, outers, inners, last. So it would be very helpful this time if we actually do cover up that second part of this parentheses. Now I'm only going to use 2 different colors for this instead of a bunch of colors, so hang on with me. If we start distributing this 12x, 12x times x squared, that's 12x cubed, because remember, x to the first power times x squared is 1 plus 2, or x to the third. We're then going to distribute again. 12x times 5x, that's 60x squareds. 12 times 5 is 60, x times x is x squared. And we're going to distribute it one more time as if this was a plain distribution problem. 12x times negative 1 is negative 12x. Okay? We're going to adjust our brain for a second and we're going to say, okay, I'm done covering up the second part of that first parentheses, and now I'm just going to cover up the first part so I can focus on what I'm actually distributing. And again, we just regular distribute. Now I'm going to do something funky here to make this problem easier. You see how 5 times x squared would be 5x squareds? And don't we already have an x squared term there? Yeah, we have an x squared term right here in the center with 60x squared. So what I'm going to do to make my life easy is I'm going to line those up to make this an addition problem at the very end, the way we did polynomial addition a class period ago. 5 times 5x, that's positive 25x. And oh snap, look, they line up now, x's over x's. And then 5 times negative 1 is negative 5. Phew. No big deal. I can just make this an addition problem. I've got everything lined up. 12x cubed plus nothing is 12x cubed. 60x squared plus 5x squared is 65x squared. Negative 12x plus 25x, that's positive 13x. And then we drop down our constant of negative 5 because it doesn't combine with anything. All right. We've made a polynomial product for this binomial times trinomial. And again, if when these problems get bigger, you really would like to use the Punnett rectangles or Punnett squares, feel free. I just know from experience of being a mathematician and teaching this class that you're going to want to be able to do the FOIL method for when this is just a sub-step of something larger, because it's so much faster than drawing your box. But if you need your box, you need the box. All right, let's move on over to division. Now, again, don't overthink this. We're just going to identify and divide or factor out. Remember, factor out means divide in this case. The GCF, greatest common factor, for these polynomials. Now, we should be able just to look at 2x squared plus 10x minus 6 and say what they have in common. Do those 3 terms, does the 2x squared, 10x squared, and negative 6 have x's in common? No, because like the negative 6 doesn't even have an x attached to it. So x is definitely not a part of our GCF. But hopefully you notice that every single one of those terms is divisible by 2. And that's the biggest number that they're all divisible by. That's the biggest factor. So we've identified that the GCF is 2. And now if I want to factor it out, remember we just like divide it away from each of those pieces and write what's left behind. 2x squared divided by 2, that's going to be x squared. 10x divided by 2, well, that's 5x, 10 divided by 2. And negative 6 divided by 2 is negative 3. And voila, I have my GCF in the front and my leftovers on the inside. Again, that is not the proper term for them, but we're going to call them the leftovers. Pause and look at number 6. Can you tell me what the GCF of number 6 is? Yeah, the GCF is 5 because 10, 5, negative 5, and 15 all have 5 in common, and not all of these three terms have an x in them. So we've identified, and now we need to factor out or divide out that GCF and give me some leftovers. 10x squared divided by 5 is 2x squared, negative 5x divided by 5 is negative 1x, and 15 divided by 5 is positive 3. Now, if you were looking for this answer choice to be written on a test, remember that the 1 would be invisible, and it would just say minus x. We've got our GCF and our leftovers after we did division or factored out the GCF. Now, number 7 is different. What do you notice that both 3x squared and negative 12x have in common? Yeah, they for sure have an x in common because like they both say x on that term, right? The x squared and x. Okay, but what is the number that they have in common? Sorry, I don't know what I'm writing now. They also have a 3 in common. So this time my GCF is 3x. And when I divide 3x away from each of these and look to have my leftovers in parentheses, 3x squared divided by x, remember your exponent rules, is going to be just x. And 12x divided by 3x is just negative 4. So very quickly, we're able to simplify my leftovers if we take out more complicated GCFs. I want you to stop on number 8. We're going to do this in 2 parts. First time, I want you to pause the video and tell me the GCF. If you were unable to look at this problem and just say, the GCF is 7x, then you might need to break these numbers apart into their factors. 21x squared is found by multiplying the prime numbers 3 times x, 3 times 7 times x. And 14 is found by multiplying the prime numbers 2 times 7, then we're multiplying it by an x. This way, we're able to very easily see that these two terms have a 7x in common. Another thing that's pretty cool about that expanded version there is if I divide away that 7x that I know is my GCF, what do you get as the leftovers? Yeah, you get 3x and a positive 2, which, wouldn't you know it, are exactly what were left over when we found the broken down versions for these particular terms. So if it helps you to write them out so you see what the GCF is, what they have in common, and what would be in the leftovers for each term, that totally works for me. So remember, we're trying to take the training wheels off of using the Punnett square method and start going into the FOIL or double distribution method when we're multiplying polynomials. We're also dipping our toe into dividing polynomials by just dividing out what's called the GCF today. We're going to get into more complicated division later on in class called factoring. It's one of my favorite things, so even if you hate it, you have to pretend you like it. But we will see you in class and we will practice these 2 skills.